Scientists are using nanofibers, which are microscopic threads made of carbon or polymers, for a variety of applications, from medical devices to smart clothing to lithium-ion batteries. But handling nanomaterials can be tricky because many of them stick to almost any surface, making them difficult to pick up and move around. Now, inspired by the way that certain spiders, called cribolate spiders, weave thousands of natural nanofibers together into strands to catch their prey, researchers have created a tool to handle lab-made nanofibers. They report their results in ACS Applied Nanomaterials. Unlike the silk from most spiders, which is coated in a sticky glue, the threads from cribolate spiders resemble a bristly wool that embeds into the bodies of their prey. To keep from getting caught in their own webs, these spiders use a non-stick comb, called a calamistrum, on their back legs. During web making, the calamistrum grabs onto nanofibers emerging from the spider's abdomen and assembles them into threads. Anna, Kristen, Joel, and colleagues wondered why the sticky nanofibers don't cling to the spider's comb. They figured that the answer could reveal new strategies for handling synthetic nanomaterials. The researchers began by shaving off the combs from a group of lace weaver spiders. In contrast to normal spiders, those lacking combs showed a buildup of nanofibers where the combs should have been. In normal spiders, the surface of the comb was covered with fingerprint-like nanoripples. This structure prevented nanofibers from closely contacting the surface of the spider's leg in the region of the comb, reducing adhesive van der Waals forces. To make an artificial non-stick surface inspired by the spider's combs, the researchers used lasers to pattern similar nanostructures onto a piece of PET foil and then coated the foil with gold. Next, the team tested the anti-adhesive properties of the structured foil. For comparison, they placed a spider's calamistrum on the end of a wire, pressed it down into a strand of spider silk, and then lifted it up, measuring how far the silk remained stuck to the comb. Then they pressed a piece of unstructured foil into the silk thread, noting that the strand remained stuck to the foil longer than the spider's comb did. In contrast, the foil with the nanorippled structure behaved more like the spider's comb, quickly detaching from the silk thread. According to the researchers, the spider comb-inspired structure could someday be added to tools used to handle synthetic nanofibers, helping scientists tame the unruly materials.